Hi, my name is Alicia Kearney, and I will be discussing my team's spring-loaded multi-chamber launcher with continuous rotation index. Our problem statement is to develop a table tennis ball launching device for beginner to advanced recreational players to be used for solo practice and enjoyment of the sport. By developing an alpha prototype demonstrating key functionality of usability, technicality, and innovation, by taking inspiration from Nerf gun toys, we were able to achieve these objectives. We began by designing our model in SolidWorks, defining the circuitry in Tinkercad, then implementing everything into Arduino so we could manufacture our prototype in the Stevens Makerspace, utilizing their Bamboo Labs X1 carbon 3D printers. This cycle was repeated countless times to ensure our prototype was satisfactory. These are all the materials we used in our prototype, including common electrical components and recycled materials, which we were encouraged to use. The team took the route of a modular design process, where we had 4 key subsystems, which we perfected individually prior to a seamless system integration. Balls begin in the revolving mechanism, then they are pushed into the launching mechanism, where flywheels send balls flying out of the launcher. These 2 mechanisms sit on top of an angle control column, which rotates the launcher side to side 40 degrees. The user interface controls the other 3 subsystems. The most unique part about our launcher is the revolving mechanism. The way that it works is there's a 2-tooth driver gear controlled by a worm gear motor, which pushes a rack backwards, compressing a spring. That elastic potential energy then serves 2 major purposes. The first being sending the rack, shooting it forwards, acting as an impactor, pushing balls out of each chamber. And it also acts as a cam follower, following along grooves in the 3D rotational cam, which rotates the entire revolver at the same time. We conducted various engineering analyses to make sure our design was structurally sound, including a weight distribution analysis, ball trajectory analysis, making sure the ball will end up on the other side of the table, a gear tooth FEA on the revolving mechanism to make sure when the spring is compressed at its maximum, the gear tooth will not yield. And the final analysis was a cam follower acceleration analysis utilizing SolidWorks motion simulation to see if the force upon impact of the cam follower would be enough to push balls out of each chamber. All of our objectives were met successfully, and the team was satisfied with the results of our alpha prototype. There are several adjustments that can be made before we can call our launcher a beta prototype. The biggest issue is that once 2 of the chambers are empty, the center of mass is no longer along the axis of rotation, which causes the revolver to rotate backwards and deflect the cam follower a bunch. To fix this, we can improve the strength of the cam follower and also improve the timing of the cam and make the revolver harder to rotate on its own. The servo motor on the angle control mechanism is very noisy, so we can double check that we're providing the right amount of power supply, and also some general improvements, improving the general aesthetic of the design, and also just analyzing the entire mechanism, making sure that each component is keeping in mind maximum weight reduction and ease of assembly for users. Thank you for listening.